today is the 30th of October 2023, and I would like us to look at how to bisect a line or perpendicular bisector. Okay. Thank you to everyone who has been watching our videos. Okay. Please subscribe, share, like, and follow. Okay, depending on which platform you are. I'll really appreciate that. Okay. In the comment section, I normally write, please follow my note/script. Okay. I've said it several times. It is a good habit to follow the notes, okay, so that you understand what I'm presenting to you and how to solve a question, especially if you are also going to write an exam, or maybe you are homeschooling. You want to show your child the right way to do the work. Okay. Now beware of scammers. Okay, I've not asked for any donation, so beware of scammers. Recap. Last lesson we looked at the topic loci, and we said loci is plural, but locus is the singular. And we look at some examples. Okay, we said there are a set of points that fit or satisfy a description. So for instance, if there is an investigation up to 10 miles from where the thing happened from, okay, from that point to the next straight line 10 miles from that point is a point of locus. Okay, I will explain that. Okay, standard construction can be used to find loci. So loci being the plural. So for instance, if you draw a circle of radius 1 centimeter, everything on the circumference is your loci. Okay, but one point on the circumference is your locus. Okay, so let's quickly look at an example. An investigation into an incident had a cutoff point at 6 miles. Okay, so for instance, there's an investigation. Something happened at a property, and they are extending the investigation up to 6 miles. So they've given you, use 1 centimeter to 2 miles and draw the cutoff points or the boundaries. So 1 centimeter is 2 miles. So 3 centimeters will be 6 miles. So if I draw 3 centimeters radius and I draw assuming this is the point of the incident, and I draw a circle around it, okay, that will be my loci, the circumference here on the circle. Okay, assuming I pick one point there, that will be my locus. Okay, if I go beyond this boundary, then I'm outside the point of interest. But everything within the radius 3 centimeters, which to scale is 6 miles, will be considered. Okay, they wouldn't go through everything, but they'll try to find clues to help them see how best they can solve that incident, especially if no one is coming forward. Okay, so the boundary are its cutoff point or loci. Okay, that was what we did last lesson. Region of investigation will be with the 6 miles cutoff and boundaries. Okay, is the locus, the loci of investigation, which I've just explained. A point of interest on the boundary is the locus. So within the boundary, there can be any point of interest, but these are all, if it's an incident, these are all, this is the cutoff point, and this is the loci of the investigation. But assuming at this point, exactly 6 miles from this point of incident, okay, that would be a locus. Okay, I hope I'm making sense. So this is what we started to look at last lesson. Now today our starter is something we've done, but we just want to revise. There is an increase of 22.5% of holiday fares to a place a family of 4 visits yearly. So this family of 4 have always gone there yearly, okay, since they were a family. Last year, they paid £920 to go there. How much would they pay this year? Now, this year, there is an increase in fare and in the package of £22.5. Okay, so we are going to find 22.5%, not £22.5, but 22.5% of this increase, and then add it to what they paid last year. So increase of 22.5% of £920. Okay, so 22.5 divided by 100 times £920. Okay, so you can do 0.225, assuming you change this into a decimal, times 920. And if you do that on the calculator, you get £207. Now this is the new increase. So you add £207 to £920. Okay, so if you add that and do that correctly, you have £1,127. So that will be the new payment that they have to pay with the fare increase of 22.5%. Okay, so this is our starter. Okay, I just thought we've done this, but I just thought I'll throw in so that we don't forget. Now today, let's look at some construction work using ruler, compacts, and a protractor. So this is a ruler here. This is a compass there, and that is a protractor. Okay. So I'm going to show you how to draw a perpendicular bisector. So assuming they ask you to bisect a line or divide a line, okay, into two equal halves, how do you do it? Okay, and that is called a perpendicular bisector, because if you bisect a line into two equal halves, it will cut the line at your line at 90 degrees. Okay, with time we will use it again to solve other questions, but today we want to see how we do that using a compass, a ruler, and a protractor. Okay, first you draw the line 5 centimeters. Okay, you are supposed to bisect the line 5 centimeters. So you use your ruler and then you draw the line 5 centimeters here. If I zoom in for you, that is 5 centimeters. Okay. So at the end of the line, the zero mark is S. The T is the 5 centimeter mark. From S, use the compass and draw two arcs, top and below. Now this arc that I use 4 centimeters. I don't know whether, so if you are here, if you measure 4 centimeters, you draw an arc here and an arc down there. Okay, so after drawing the line, you draw an arc here and you draw an arc here, and then you go also to T with the same radius, with the same compass. You draw an arc here, you draw an arc here. You don't change the length of the arc using the compass. You use the same length. So if you measure this on the ruler, it's 4 centimeters that I opened it up to. So from S and a compass, you draw two arcs, top and below, as I've just shown you. Do the same at T, which we have done. Join the 2 points of intersection Q and R. So these two arcs that we've drawn from S and T, top and below, this is how they will look. Okay, so this point of intersection and that point of intersection, we are going to draw a straight line. Okay, that will be our Q, that will be our R. Okay, now what have we done? We've divided the line into two of 5 centimeters into two equal halves. This point, okay, is 2.5 centimeters. This line here, our perpendicular bisector, will cut, is perpendicular because it's at right angles. We'll cut the line at 90 degrees. Okay, so what have we done? We have just dissected the line with a midpoint at 2.5 centimeters. The perpendicular bisector SC, okay, or divided the line SC in two equal parts with the line QR meeting at right angles or rectangles. So if you see that point here, okay, let's zoom in again. That point here is 2.5 centimeters. Okay. If you can see clearly there. Okay, 2.5 centimeters. And it will meet our line ST at right angles or 90 degrees. Okay, so this is how we divide the line. Okay, so we are going to look at a few examples today. Okay, now let's note some points. Okay, I always stress on the introduction, because if you can remember the introduction, everything builds on there. Okay, and you can use that, apply that to solve future work. Okay, so any point on the back bisector QR is middle of SC. So if I take this point, okay, from this if I take this point, sorry, here, from S to this point will be the same distance from T to that point. Okay, you can draw it and find out. If I take this point here, from S to this point will be the same distance from T to the same point. Okay, any point left of the line QR is closer to S than T. So this is our left part. Okay, any point here, okay, will be closer to S than T. Vice versa, any point on this side of the line will be closer to T than S. Okay. The perpendicular bisector is used to find the midpoint of the line segment, which I have just told you from the beginning. So if you are told to find the midpoint of the line 6 centimeters, what they are actually telling you is find the perpendicular bisector. So you draw the line, you use your arc, your compass, same length, draw an arc at the top, and then at the down from this point, the edge, okay, and then the same arc length on the compass, you draw an arc again, top, where they intersect, you use a line to connect them. That is your perpendicular bisector. Set of points, line equidistant from 2 points. So as you can see, okay, all these points are equal distance from the line. So if you take this point and that point, they have equal distance from the line here. If you take that point, this point to this point, and that point have equal distance. The region closer to 1 point, there is region closer to 1 point than the other. I've also explained that. So this region here, okay, is closer to S than to T. And that region here, all this place, is closer to T than S. Okay. Now let's do a few examples. So find the perpendicular bisector of the line 7 centimeters. So first of all, you are going to draw the line ST 7 centimeters with a ruler. So since they haven't given you any scale, they said 7 centimeters. So first of all, you take your ruler from 0, okay, you draw 0 to 7. As you can see, it's 0 to 7. Then you open your compass to a reasonable size. Okay, I use 4 centimeters because I didn't want to be changing it. So you draw the arc there, one there, and then another one down here. Okay, and then you go to this point again, you draw an arc there and another one down below. Now you have 2 points of intersection on top of both lines. You join it to the line. It will be the line at 90 degrees. Okay, and this is your perpendicular bisector. If you measure, it divides the line exactly at 3.5 centimeters. So if you look at this, okay, that is 7 centimeters. If you zoom it, exactly 3.5 centimeters. Okay, there, that is our point of intersection. Okay, again, we've bisected the line, we've divided the line into 2. Now let's look at our last example again. Okay, so if they ask you to do a perpendicular bisector or divide the line into 2, this is what they are basically asking you to do. Okay, it's a construction work. Okay, so here our line is 4 centimeters. So first of all, you get a ruler and you draw 4 centimeters. So that is your 4 centimeters here. Okay, try and be as much accurate as you can. So 0 to 4 centimeters. So we got 4 centimeters. Again, I didn't change the size. So at S, okay, at S here, okay, I try and cut 4 centimeters with an arc. Okay, use the same arc length, don't change it. And then I do one at the top and do one below with the same size. Okay, and then go to that is T, at T. Okay, and then at S as well, there, cut it there, and then do the same here. And then where they meet, I draw the line. Okay, so now this is 4 centimeters. They should divide exactly at 2 centimeters. So as you can see, exactly at 2 centimeters if you draw it well. Okay, if you draw it well, it should be exactly at 2 centimeters. The line that bisects the line should go through your 2 centimeter mark on your ruler. And that's the midpoint. Okay, so it looks simple and everybody should be doing it. If it is 2 marks, you've just got a free 2 marks in an exam paper without doing any calculation. Actually, guess by the knowledge of knowing how to divide the line. Okay, so today what have we been looking at? We've looked at our recap on loci. I've brought in an example of an incident 6 miles away from a point.